share. Yeah, I hope you can see my screen. Yes, now it's visible, I believe.
Yes, sir.
Yes, sir.
Okay. So then,
So,
with irrigation, mining, etc., basically what happens? We have to now suppose transfer and transform motion or power from one place to another. Like previously, very in the very beginning, people knew suppose when the wind comes, okay, heavy wind, then they are basically their shelter, etc. They are also okay. So from there, someone realized that means this particular thing, that means the wind power or maybe power from the water, that can be harnessed. If I can harness or like from here I can get something done, okay. And so from there actually irrigation mining those kind of concepts, okay, where basically transforming as well as transferring motion and power from one place to another require those things came up, okay. Now that means a higher level of civilization, higher level of mechanism. So from there you can consider like the transferring and transforming motion and power means what? Transferring means from one place to another. Transforming means from one, what? Transforming means one type
from
to
one
another.
form to another. So,
Yes, from one form to correct. So from one form to another. Okay. So now suppose let's consider wind energy that is available in the form of like the wind, all of you already know. Now only with respect to that I will not be able to do anything. Okay. Now people have like that initial windmill, etc. They have developed, and from there the motion of that particular wind blade, okay, whatever nowadays we call as wind turbine or like that. Okay. So that has been from there we are going to use that gearing mechanism. Okay, and we are going to use that particular, we are going to harness it, okay. So those kind of things came up. Now after that only there once again if you say okay, only if I can do like I'm sitting there, okay, and maybe I'm able to say sit properly or stay in a comfortable manner safely and like that, and I'm also able to do irrigation mining, etc. Only that also is not enough. Now what happened, people are saying like if I have this particular type of transformation or transferring motion that I can do, but now if I can do it in a kind of multiplication, okay, that means if I can multiply force or drop, or you can say like initially only at a lower speed I am able to perform something. Suppose some automation I have done, but it's been happening at a kind of lower speed. So once again we are like kind of somewhat greedy. So I need now that means if I can get certain higher speed, that will be good, okay. Then at high speed of rotation if I can do, that will be another advantage. So now like the concept of, if I say what the concept like the use of gears, that the different sizes of gears, so as to get the speed reduction or increase in speed, those things came up, okay. Similarly like torque reduction or multiplying the force, those things came up. Similarly sometimes what happens if I am able to do something, okay, okay, that's I am, let's consider I'm able to make something in a particular shape. Now that shape is something like not a properly geometrically accurate. So now the need for geometrical perfection, okay, that has came up, and for that also we have got so many mechanisms, okay. And similarly to guide, suppose if I am gradually if I am going for somewhat automation, that means with less human intervention I am able to do something, okay. So in that particular case where the requirement of accuracy as well as precision, it has also came up, okay. It's not like initially if you could do within a certain range, okay, and after so many years, so if we are doing only in that way only, that is not the advancement. Our goal is always we want to strive hard, okay, so that we can advance, okay. Advancement in the sense of like I have already said, multiplication of maybe four star, or maybe you can consider like the initially whatever is the speed, okay, I need to go for higher speed. Maybe can consider if I'm loading capacity previously was supposed to limited, I want to go for high load capacity. Similarly, geometrical perfection, if it is somewhat less, I want to go for higher perfection. Those are some of the needs, right? And that has given rise to so many nowadays whatever different mechanisms, and using those mechanisms, whatever machines that we use. So actually, that is the you can say result of those things. Okay, the accuracy, precision, the repeatability level, those are some of the requirements. So the requirement may be in terms of your human comfort, in terms of developing a particular thing which is with particular thing, or that means particular machine will be later on calling as machine or mechanism depending on what is the use. So developing that particular system, okay, for doing a certain task at a faster rate in a accurate manner like that, okay. So which might be used in your day-to-day life, maybe in a different way than that of day-to-day life, like maybe some manufacturing, maybe you can consider some machine, etc., which has been used for manufacturing purpose, and ultimately those manufactured part somehow or the other in your life you are using. That means the concept of having doing all those things, which will be ultimately done by means of some mechanism, okay, which will be used in the machines, etc. We are going to do all those things, okay. So that is that. And all of you already know with the in the, you can say, during the industrial revolution, so actually tremendous growth of mechanisms and machine it has taken place. And during those course, previously whatever people thought like kind of magic, okay, it's called now one man magic is another man's invention. Yes. So if you have invented something, initially it will look like magic to others, right? If today you can make a time machine, let's consider. So for us, it will look like kind of magic. Yes or no? Partha is always thinking about time machine, right? Yes. And Rehan also, I think.
Yes, sir.
Okay, so if you can do that, so initially it will look like magic. Later on, if I know the trick or the mechanism or the way to, or means how to develop it, so it will be kind of normality. So that is what is always happening. Okay, initially the car, okay, automated car, people are coming from the, like from the bullock cart to car. Okay, that conversion it looked like magic, but it actually someone actually built it. Okay, and that you people can also be that someone. So learn these things properly. So now what happens nowadays? What happens? So if you need to now you understand that means why it is required, right? Why it is important, what kind of thing it can do, ultimately how it is affecting our life. All of you can understand, right? All of you agree with me?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay, okay. So now as these are all those requirements, so if we need to also develop something, okay, if we need to design a mechanical system, so we have to have the proper understanding of first the geometrical aspect of the motion. Okay, that means how basically the geometry or the shape, size of the links, etc. Those what is link, what is pair, those things we'll understand, we'll discuss. Okay, but the geometrical aspect of the motion we must be able to understand properly, because arbitrary kind of motion if we get, that's not enough. And similarly how the link length, how the location, etc. is affecting this motion, that also you must know. Similarly, the various forces which are also involved in that particular method. Those things also, these two things, requirement of for this proper understanding of these two things is very much important. Okay, so that is the basic. So now we know that means what is the need of it, how basically it is getting developed like that. Okay, and now if we have or if we want to discuss about this theory of machine, so what is this? So now this theory of machine we can consider as a branch of engineering, okay, which is basically dealing with the different relative motions and different forces between various machine elements. Okay, so basically two parts are there. One is the kinematics of machine and another one is the dynamics of machine. Okay, and the I believe from your em knowledge also you people have idea about kinematics and dynamics. So now the subject which only is dealing with the geometrical aspects of motion, and we are not considering the forces involved in the system or the system inertia, that is basically known as the kinematics. Okay, so basically it is dealing with the geometrical aspects of motion, and we are not considering the forces involved, or neither we are considering the system inertia. So that is the kinematics. And basically when the system inertia as well as the different forces, interaction of forces, also we are considering that branch becomes dynamics. Okay, and I believe all of you already know when the system is in equilibrium and under the influence of different applied forces. Okay, that is nothing but statics. Okay, that's statics. And whenever we are dealing with a system which is in motion, that is nothing but kinetics. Okay. And whenever we'll be dealing with the different parts of, you can say, machine, etc. Then we must know to understand. We must have the understanding of rigid and resistant bodies. So from your previous knowledge, I believe you people know from your engineering mechanics knowledge what is rigid body and what is resistant body. Any example? So from your particle physics also you know, right? Rigid and resistant bodies. So now basically rigid body is something we can define it as like a kind of body, okay, which will not undergo or will not suffer any kind of distortion. Or ultimately, if you consider any 2 point on that particular body, okay, the distance between these two point will remain same under the influence of force. Okay, that means during the action of force, it is not going to be distorted. Okay, or it will the distance between 2 point if you consider it will remain constant. That is the rigid body. Okay, it's a kind of ideal body you can consider. Okay, and resistant body is something which you can consider which is capable of transmitting the required force with negligible or no deformation of it. Okay, and these resistant bodies are something it can be considered as rigid body for that particular purpose they are going to solve. Okay, that means if you have selected a particular element and whatever is the loading condition, the required force condition, okay, which will be transmitting or which will be applied on that. Okay, and within that limit, if it is not undergoing any uh, say then it's I can say or any deformation, okay, then that body can be considered as resistant body. And practically speaking, the bodies, the elements that we consider in different machine mechanism, etc., are actually resistant bodies. So rigid body is a concept of kind of you can consider like a kind of ideal concept. Okay, understood? Any confusion up to this much?
No, sir.
Okay, so now all this time we have been dealing with this towards mechanism as well as machine. Now how to define them, how to define properly. So mechanism, how I can define. So it's, we can consider now all of you already know rigid body, resistant body. Okay. So now
Sir,
using this concept, yes, yes,
Sir, can we say rigid body as that type of body which cannot be deformed into any other shape?
and that is what I am saying. Na? If you are applying any can say force, okay, it will not undergo deformation. Those are rigid body. Ultimately, no deformation under the application of force. Okay.
Yes.
Okay. So now mechanism if you are talking about. So basically, we can consider to be a kind of combination of different numbers of either rigid or resistant bodies which are being assembled in a such a way that the motion of one it is going to cause kind of constraint or predictable kind of motion to the other elements which are connected to them. So that particular system will be known as the mechanism. So what is constraint motion? So constraint motion is kind of a predictable motion. Okay, that means you know how it's basically actually going to behave, in which way it is going to go. Okay, so how it is able to move. Okay, or which way, or you can say how it is allowed to move. That is kind of the constraint. Ultimately, it's a kind of predictable movement. Okay, it's not like you're connecting something, some rigid body or resistant body, certain by certain joint, etc., and arbitrarily it is giving you some motion that cannot be considered as a mechanism. So mechanism has to give you some constraint or predictable kind of motion. Okay, and generally our purpose of making a mechanism, it's not like suppose only for fun you're making mechanism, you're just connecting something of rigid or resistant bodies, etc., which is giving some motion, etc., and you're just making fun. So it's not like that. So it has got some function, and basically we are using the mechanism to transmit as well as modify motion. Okay, and another definition of mechanism also is there which can be dealt with respect to the concept of kinematic chain. So then when there is a any one link of a particular kinematic chain is fixed, basically it is also going to form a mechanism. So that is with respect to the concept of kinematic chain, that is the concept of mechanism. Understood? Mechanism you have understood, right? So why we use it, basically transmitting and modifying the motion. Okay, and during that particular process, transmitting and modifying the motion, actually some process are also involved, and through the link, which are nothing but rigid or resistant bodies, and they have been assembled in such a way that ultimately motion of one is going to provide some constraint or predictable motion to the other links. Up to this much, any confusion? Okay. So now that is about mechanism. Okay, so mechanism you can consider it's just like the building block of any machine. So sometimes a single mechanism may also become a kind of machine, and generally a machine is a combination of so many mechanisms. So now, so a machine you can consider like a combination of mechanism, which apart from just imparting motion to the parts, okay, also they are transmitting and modifying the available mechanical energy into some kind of desired form. Okay, so it not only is involved with just transmitting and modifying the motion. Okay, it is also dealing with concept of conversion of, you can say, like this, or transmitting or modifying the mechanical energy into some kind of desired form. It can do some work. Okay, but it is neither a source of energy or not a producer of work, but it is actually going to help you in proper utilization of this. Okay, so in this particular case of machine, generally in the initial source of energy, or you can say the motive power, it has to be derived from some external source. Okay, maybe electrical starter, or maybe some fossil fuel, or whatever it be it. Okay, so the motive power has to be derived from the external source. Okay, and we are going to use that particular machine to transmit both motion and force. Okay, and there is another concept later on we'll understand, that means what is successfully constant motion, what is partially constant motion. So constant motion, types of constant motion we'll understand, but you must know that here the relative motion between the different links. So these links are nothing but the building block of your mechanism. Okay, connection of different links gives rise to the mechanism. So here the relative motion between the links, they are successfully constant. Okay, so this is basically about mechanism and machine. So there may be concept of, like, I believe all of you already have heard also about the engine. So can anyone tell me what's the basic difference between machine and engine? Or you also have heard about different structures, right? So from this discussion, can you
The
tell me
engine
what's the
supply
difference between
power, sir.
machine and structure? Please repeat.
Basically, sir, engine provides energy, sir. Like it runs the machine.
Engine does what? Energy. Just, your voice is being distorted actually.
Sir,
So it
one
gives energy
consumes
to the machine.
energy.
Like it,
One by one, one by one. Yes. Anyone can start. Hello.
Sir, sir,
Yes. Yes. Yes.
sir, a machine consumes energy, and
Okay.
the
What about
engine
engine?
does and the sir, and then engine sir produces the energy. The opposite thing of the machine.
Okay, you can say something like that. And is there any similarity between them? Is a engine machine? Is an engine a machine?
Yes, sir.
And is a machine an engine? Always an engine?
Yes, sir. They both does some work.
No, they are doing work. Okay, that's okay. Is machine an engine? Okay, is a machine always an engine?
Yes, sir.
Yes or no? मशीन होने
Yes,
से ही वो
maybe, sir.
इंजन होगा क्या हमेशा?
No, sir.
No, but एक इंजन होने से it is always going to be a machine, or not?
Yes, sir. If it's engine, then it's gonna be a machine.
Okay, so that is one of the. And what about machine versus structure? So I think these two things you can consider. You can just go through maybe some books, internet, etc. Just try to check what are the similarities, what are the differences, right? Machine versus structure. why we are going to, what is there any similarity, okay, is there difference, what are the differences, or why we use this, why we use that, okay, or when it will be called as a machine, when structure, or maybe machine versus engine. Okay, these two things are kind of your homework for the next class. Okay, so with this we'll then stop for today. I'll just take the attendance. So any confusion, if you have any, you can ask. If
About
no,
structure, sir. Machine with structure.
yes. So that is the homework I'm giving. No? Structure basically your, if you consider your that building or debris, etc. They falls under the category of structure. Now, can you tell me, like, will there be any similarity or difference? Why we use this? Why we use that? Or in terms of, maybe if you can call in terms of degree of freedom, I believe from your previous knowledge, degree of freedom, that concept you have, all of you have. Okay, don't worry, if you just go through it. Otherwise, we'll discuss in the next class. Okay, is that okay? Okay. So respond to your name first. Nilutpal, absent. Shankar,
Yes, sir.
Arshishman, Arshishman, absent. Then Rehan,
Present, sir.
Artha,
Present, sir.
Rishikesh Basumatari,
Present, sir.
Hermiki,
And sir.
Nohasol.
Yes, sir.
His is also present. He's writing in the chat. Okay, Rishikesh Nath
Yes, sir.
and Emil. Emil seems absent. Okay, so thank you everyone. We'll meet in the next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.